What is Sloppy Python? Talusani Dutin Reddy. Class CSITA. Roll number 22951A 3326. Introduction. When a user enters a query into a web search engine, they do not expect it to return a syntax error. Imagine a user searching for end-user programming and getting an error like unexpected token programming. Not only to do users not expect to see such as an error, but they expect the search engine to suggest the proper spelling of programming. In effect, users expect the engine to try everything within its power to make sense of their input. The burden is on the search engine to make the user right. People have come to expect this behavior from search engines, but they do not expect this behavior from programs, compilers, or interpreters. Sloppy programming. The essence of sloppy programming is that the user should be able to enter something simple and natural, like a few keywords, and the computer should try everything within its power to interrupt and make sense of this input. The question then becomes, how can this be implemented? One key insight is that many things people would like to do, when expressed in English, resemble the programmatic equivalents of those desires. For example, consider the case where a user is trying to write a script to run in the context of a web page. They might use a tool like Chicken Food, which allows end users to write web customization scripts. Now let's say the user types. Now click the search button. The user shares certain features with the Chicken Food command. Click search button, which has the effect of clicking a button on the current web page with the label search. In particular, a number of keywords are shared between the natural language expression and the programming language expression, namely click search and button interface. Our prototype system have used two main interface for sloppy programming. The first is a command line interface where the user types keywords into a command box and the system interprets and executes them immediately. Note that although commands traditionally require verb, the sloppy queries may be suggestive without using an imperative verb. For example, consider the query left margin 2 inches in the context of Microsoft Word to a human reader. This suggests the command to make the left margin of the current document 2 inches wide. Such a command can be expressed in the normal language of Visual Basic as active document. Page setup. Left margin is equals to inches 2 points. A sloppy command like line system would try to perform this translation automatically and then execute the Visual Basic behind the scenes to achieve the user's intent. Benefits. Sloppy programming seeks to address many of the issues raised previously. To illustrate, consider the left margin 2 inches example. First, note that we don't require the user to worry about strict requirements for punctuation and grammar in their expression. They should be able to say something more verbs like set the left margin to 2 inches or expressed in a different order like 2 inches margin left. Second, the user should not need to know the syntactic conventions for method innovation and assignment in Visual Basic. The same keywords should work regardless of the underlying script language. Finally, the user should not have to search through the API to find the exact name for the property they want to access. They also should not need to know that left margin is a property of the page setup object or that it needs to be accessed via the active documents systems. Over the past few years, we have built a number of systems to test and explore the capabilities of sloppy programming. Three of these systems take the form of command, like interfaces for interacting with websites. These systems explore the usability aspect of sloppy programming without worrying too much about the implementation. Since the underlying command set is fairly small, so even a Navi implementation is fast enough for real-time use. The fourth prototype explores sloppy programming in an integrated development environment for Java, where the system needs to generate valid Java expressions in real-world Java projects. This system requires thinking more deeply about the algorithm, though we mainly discuss the UI challenges relevant to the IDE domain here. Sloppy Web Command Line. Our system prototype system tested the hypothesis that a sloppy programming command line interface was intuitive and could be used without instructions provided. That the user was familiar with the domain. The web domain was chosen because many end users are familiar with it. The systems take the form of command interface which users can use to perform command web browsing tasks. The system is a plugin for the Firefox web browser. Important UI elements are shown here. The GUI for this prototype consists of a text box affording input A and an adjacent horizontal bar allocated for the textual feedback B. Inky commands. A command consists of keywords matching a website function along with keywords describing its parameters. For example, in the command reserve D 463 3 pm, the reserve keyword indicates that the user wants to make a conference from reservation, and D 463 and 3 pm are arguments to that function. Like the other sloppy interrupts discussed previous, the order of keywords and parameters is usually unimportant. The order of the entered command matters only when two or more arguments could consume the same keywords. For example, in the command reserve D 463 3 pm 12/2007, it is unclear if 1 is a month and 2 is the date or vice versa. In find flight SFO LAX, it is unclear which airport is the origin and which is the destination. In these cases, the system will give higher rank to the interpretation. The essence keywords to arguments in left to right order, but other ordering are still offered as alternative to the user. Commands can use synonyms for both function keywords and arguments. Quack-Ellipse plugin. For our fourth and final example of a sloppy programming system is a departure from the previous system because it targeted both a different domain, Java programming rather than web browsing, and a different user audience, professional programmers rather than end users. Quack 26 is a plugin for the Eclipse integrated development environment that explores both the speed and usability of sloppy programming is the domain of general purpose Java programming. The plugin integrates with Eclipse Java editor and provides a new kind of autocomplete feature. With the Quack plugin installed, the user may enter sloppy queries directly into the source code. The following figures show the user entering the sloppy query and add line. Algorithm. All of the systems described above need some way to converting a sloppy query into systematically valid code. These sections describe two approaches for performing these translations. The first approach assumes that the possible iterations for a sloppy command is limited mainly by what is actually possible in the current context. This is the case in a typical form-based web page. where the number of commands is roughly proportional to the number of form widgets. This algorithm was used in the Koala system. The second approach assumes that the possible interaction in the current context is extremely large and that the only effective way of searching through it is to guide a search using the keywords that appear in the slope query. For this approach, we focus on a slow but easy to understand version that was actually used in the web command prototype. We then provide high level insights into some improvements that can be made to the algorithm. Along with the reference for more details about these improvements, the more advanced algorithm was used in the Inky and Quack prototypes. Algorithm. First, the interpreter simulates all possible actions associated with the various HTML objects in the document, such as links, buttons, text boxes, combo box, options, checkboxes, and radio button. For each of these objects, the interpreter associates a variety of keywords, including the object label, synonyms for the first object type, and action verbs commonly associated with the object. For instance, the first name field of web form shown above would be associated with the word first and name because they are a part of the label. It would be associate text box and field as synonym of the field type. Finally, the interpreter would include verbs commonly associated with entering into a text field such as enter, type and write. Next, the interpreter searches for the object that matches the greatest number of keywords with the sloppy input sequence. The example text box A would match the words type, first name and field with a score of 4. In contrast, text box B would only match the words type and field with a score of 2. Web command line algorithm. Functions are building blocks in the algorithm. Each function returns a single value of a certain type and accept a fixed number of arguments of certain types. Literals like strings or integers are represented as functions that take no arguments and return an appropriate type. We can implement optional arguments for functions with functions. Overloading functions can have many names, usually synonyms of the true function name. For instance, the enter command in the web prototype has name like type, write, insert, set, and the symbol. In addition to its true name, enter. Functions for literals may be thought of as functions with names corresponding to the textual representation of the literal. These names are matched programmatically with the regular expressions. Example, integrals are matched with 0 points. Algorithm optimizations. The algorithm desired is too slow in practice for applications like the Quack plugin, which builds expression over hundreds of object types and the thousands of functions. In order to deal with the large scale, we have explored a number of ways of making